Today I answer your questions on the eclipse. Also, astronomers have viewed two worlds colliding 1,800 light years away. Let's take a look at it on today's Astronomy and Coffee. Well, hello to you all. Happy Monday to you. This Monday the 16th here. Well, a couple days ago, we had the annular solar eclipse. Actually turned out quite nice. Very nice day to have this eclipse, to view this eclipse. We had a sidewalk viewing over at the Yazoo Plaza here at work at the Louisiana Art and Science Museum. Nice turnout. Lots of really cool people showed up and stuck around for the entirety of the eclipse. They took pictures. They viewed the eclipse through the telescope that we had out there. And we also had some glasses for them to use as well. So very nice turnout. We had a great time out there, but not really but we did have some questions. I had some questions from people regarding the eclipse, the partial annular eclipse. And one person asked me a pretty good question that I haven't really been asked before, and that was, will we experience any drop in temperature as the eclipse is getting to its maximum? To which I responded that we probably won't witness any or sense any type of temperature drop, and there are a few reasons for that. So let's get into whether or not the temperature will change during a solar eclipse of any kind. Well, there are certain factors, first of all, to consider when it comes to this question. The time of year, the time of day, the type of eclipse that is going on, the coverage of the eclipse in your particular area, etc. So for the annular eclipse that we had here in Louisiana, we didn't really feel any type of significant drop in temperature because we're currently in fall when the temperature is already rather cool. It was also around noon when the sun was already kind of beating down on us and there was no cloud coverage at that time. Now in Louisiana, we're in what is called a humid subtropical environment, and this has a lot of moisture in the air. Now the atmosphere, the air moisture, the time of day, this all affects things. So whenever we have a partial annular eclipse, which is what we had on that Saturday, we won't really expect to really sense any type of real significant change in temperature. Now, that isn't to say that there isn't some type of change to the temperature. There is, but it is not significant enough for us to really sense it. It's kind of the equivalent of being outside on a hot day, particularly here in Louisiana, and then going and finding a nice spot under a shade of a tree. So for example, I'm sure you remember the past summer and how hot it was in this past summer. You also remember how hot it was at night as well. It just didn't seem to cool off at night. Well, that is because the sun wasn't even out, but the temperature stayed rather warm because the Earth retains that heat. Now, the water loses its heat rather slowly, but the ground loses its heat even slower. The Earth stores this heat during the day and releases it at night. There's also the greenhouse effect to take into consideration, as well as geothermal heat, which also helps things out. Now, things will certainly be different if we are in the path of a total solar eclipse. If you're in a more arid environment and in the path of a total solar eclipse, you could actually feel a decent drop in temperature, sometimes up to 10 degrees. But for us here in Louisiana, it's about the same as going outside and experiencing that heat of the summer Louisiana air and then going under a tree and not really getting a whole lot of relief. Now, another question that was posed to me was, how often do eclipses take place? I think the real question is, how often does an eclipse take place over a certain part of the Earth? Well, eclipses actually happen quite often, and by that I mean that solar eclipses of any kind will occur on average 2 to 5 times a year. And there must be at least 2 per year, but there can't be more than 5, so about 72% of all years have just 2 solar eclipses, and about 0.5% have 5. Now again, the real question is, how often does an eclipse happen over a certain spot? That's what we really want to know. Well, how often is a particular spot on Earth in the path of totality? So on average, a given spot will experience a total eclipse every 375 years. This also depends on which hemisphere you're in. So if you're in the northern hemisphere, a total eclipse will occur over a certain place every about 330 years. But if you're in the southern hemisphere, it will take place over a certain place every 540 years. Well, this raises a whole new batch of questions, doesn't it? Well, this is because though eclipses are just as likely to occur in the northern hemisphere as in the southern hemisphere, each hemisphere sees more of them during its summertime, when the Earth is tilted toward the sun. Since Earth is at the farthest point in its orbit in July, which is the northern hemisphere's summer, the sun's apparent size in the sky is relatively small then. This means that solar eclipses at that time of year are more likely to be total because the moon is more likely to appear larger than the sun. So, observers in the northern hemisphere are more likely to view total eclipses, and those in the southern hemisphere are more likely to view annular eclipses. So, you're probably asking now, when will Louisiana have the next total solar eclipse? When is our next total solar eclipse? Well, that won't be until August 12th, 2045. So, will I still be here to do a sidewalk viewing of that? I don't know, maybe. Probably not. But that doesn't mean that you can't travel to an area close by to experience a total solar eclipse. In fact, next year, there will be a total solar eclipse that you can travel to relatively pretty close by. So, areas of travel that you can go to experience a total solar eclipse next year is going to be, you can go to Arkansas, Illinois, Indiana, Kentucky, Maine, Michigan, Missouri, New York, Ohio, Oklahoma, Pennsylvania, Tennessee, Texas, or Vermont. So Texas might be your best bet. Texas or Arkansas might be your best bet. Now, which state out there has to wait the longest to experience their own totality? I'll give you a second to think about it. That's going to be Iowa. Iowa will not experience a total solar eclipse again until October 17th, 2153. Sorry, Iowa. Well, like I said at the beginning here, astronomers and scientists have observed an area in the sky some 1,800 light years away that has experienced two worlds smacking into each other, creating this vaporized dust donut around its star. The star is called asassn 21QJ, which is what I call asassn 21QJ. Well, this can be found in the constellation Puppis, and like I said, it's 1,800 light years away. Now, this is a huge cloud of debris. I wish I had a model to show you this, but it's not in any of my software that I have here, but I can come up with something. Well, all this began with the All-Sky Automated Survey for Supernova. The All-Sky Automated Survey for Supernovae, or Novae, whichever one you want to pronounce. This sent out a notice regarding the star's sudden dimming. It was an automated response of a star that was suddenly dimming. Well, this prompted scientists to take a look at this area, and what they discovered was a region that produced a new source of heat 2.5 years prior to its dimming. Now, they concluded that two large bodies collided and vaporized, creating this dust ring around the star, which ultimately led to the formation of a new planet. Now, we haven't seen this, but it will eventually form into a new planet. And this dust cloud dimmed the apparent brightness of the star. So they kind of did some examinations and looked at the infrared that was being produced here and concluded that around 2.5 years prior to this, two ice giants are things like Neptune and Uranus, smashed into each other to form this dust cloud. Now, in a few years, it is believed that this debris will smear and eventually begin to form a new planet, which we will be taking a look at. Now, an alternate theory of this is that some comets collided, but the prevailing theory is that it is the result of two ice giants smacking into each other. And folks, with that, I'm going to call it a day with this Astronomy and Coffee. And yes, I do have my coffee with me today that I've been enjoying, as well as going and getting me some scones. I'm going to refresh my coffee to enjoy those delicious scones, which I don't even know. What is this going to be? Yes, the apple cinnamon scones. How to start your day off right. Some apple cinnamon scones and some coffee with some updates on what's going on out there. Next week, maybe we'll look at what scientists have discovered in that sample that was returned from Bennu. And I'm sure something else is going on out there. With that, have a great rest of your Monday. And also, wait a minute, I haven't talked about this yet. Of course, there is the Halloween Day at the Museum. I must mention the Halloween Day at the Museum. That's coming up on October 28th. You got to come see us on October 28th for our Halloween Day at the Museum, because there is going to be the Harry Potter show, the Astronomical World of Harry Potter show, a fan favorite, a crowd favorite. We only take this show out once a year or so. So this is what I call the McRib of planetarium shows. It only comes out for special occasions. In this case, the Halloween Day at the Museum. And we also have the Worlds Within Star Wars is going to be a show, and also the Fright Light laser show at 4 o'clock. So Harry Potter show at 3 o'clock, Fright Light at 4 o'clock, Star Wars show at 2 o'clock. And you can't get tickets online, so you have to get tickets here. So first come, first served. Hands-on activities start from 12 o'clock to 5 o'clock. We will be open at 10 o'clock. Hope to see you then. Lots of hands-on activities, lots of things to do. One of my favorite days here at the museum is Halloween Day at the Museum. See you all October 28th this year from 12 to 5. Halloween Day at the Museum. Have a great rest of your day, great rest of your week. Enjoy your coffee. See you next week for Astronomy and Coffee.